So before we write any lines of code, we need to write our algorithm. Our algorithm are the steps we're going to use to solve the problem. So one way to write an algorithm is to start with the input. What do we know? What are we going to be given? And so the input to our programming problem is written right here. The user is going to input the weight in pounds and radius in feet of a sphere. So we know that we are given the weight and that we're also given the radius. What else do we know? We know one other thing. We know the volume of a sphere is computed by 4/3 pi r cubed, and we know the specific weight of water is 62.4 pounds per feet cubed. So we can write that down too. Specific weight of water is 62.4. And we'll write this equation in a second. After we realize our inputs, now it's time to figure out what our output is going to be. What do we want our program to do? Inside of our specification here, it says that we want our program that will output whether the sphere will sink or float in water. So our output is going to be whether the sphere will float or sink. Now that we have our input and we have our output, so we have point A and point B, we need to figure out how we're going to get there. And so many times we'll write our algorithm in steps. So the processing part of our algorithm we're going to write in steps, such as step 1. What's the first thing that we need to do? Well, we need to get our input from the user. We need to figure out the weight and the radius of our sphere. Step 2. What do we want next to happen in our program? So what we want to happen next is we need to figure out whether this buoyant force is greater than or equal to the weight of the object so that we can output whether it will float or sink. Now to figure out the buoyant force, we need to know the volume and the specific weight of the fluid. Now we're given the specific weight of the fluid, specific weight of water. So we have that part of our equation. So we need to figure out the buoyant force, and we know it's equal to the specific weight of water multiplied by the volume of the sphere. Now what is the volume of the sphere? That's given in our programming problem. The volume of the sphere is 4/3 pi r cubed. So we'll write volume here instead of our algorithm. And we know that there's going to be a step in between step 1 and step 2 in which we're going to have to figure out that volume. So our volume is going to be 4/3 pi r cubed. So we can write that down in pseudocode. 4/3 times pi, which will make a constant, times radius, times radius, times radius. And that would be pi r cubed. Now we can figure out that buoyant force. Volume times the specific weight of water. What do we want to happen next? So step 3. Well, we want to check if that buoyant force, so if this buoyant force is greater than or equal to the weight of the object, then it will float. So what was the weight of our object? That was an input. The buoyant force is greater than or equal to the specific weight of the object. Then we know that we can output our output, which will be it will float. Now if it fails in step 3, and step 3 is false, so we can write it as an else. Else output, it will sink. Notice we've started with our input, we've ended with our output, and we've created the steps to get there. Now all we have to do is code it.